Hi friends, in this video, we are going to discuss about maxima and minima of a function by using Lagrange's multiplier method. For example, let's say I have one function f of x, comma y, comma z. So this is my function in three variable x, y, z, and these three variables are related by the relation. So here these three variable x, y, z are related. Let's say this is my function and these three variables are related by the function. Let's say phi of x comma y comma z equal to, let's say, 0. This is my constraint. So this is my constraint. So this is my objective function, and with this subject to the constraint phi of x comma y comma z equal to 0. This means that this variable of my function x y z are related by this constraint. This is the meaning of this f of x and phi of x comma y comma z. If I want to find the value of x y z for which my function is either maximum or minimum, let's say here, if you want to find the value of x comma y comma z, the value of x y z variable for which f of x comma y comma z is either max or min. So here, for example, let's say if you want to find the value of x y z for which my function f of x comma y comma z is either maximum or minimum, so here for that purpose we need to create one auxiliary equation with the help of this f of x and phi of x comma y comma z. Let's say here create one auxiliary equation as f of x comma y comma z plus lambda times phi of x comma y comma z, which is equal to 0. Let's say here I will give this as equation number 1. So here this is my Lagrange's equation with, so this Lagrange's equation, this is my auxiliary equation with lambda, so which is undetermined multiplier. That undetermined multiplier is called Lagrange's multiplier. This lambda shows the, if lambda is bigger, so your constraint have more effect on your objective function. If lambda is here, if lambda is more, your constraint has more effect on this objective function, and if lambda is less, this means that your constraint has less effect, less effect on this objective function f of x comma y comma z. So here this is the use of Lagrange's multiplier lambda in auxiliary equation. So here this is my Lagrange's multiplier. Now this is my equation 1. Now I want to partially differentiate this equation with respect to x, y and z. So here this is the constant multiplier, this is not the variable. So here x, y, z are the variable, this is the Lagrange's multiplier. So here partially differentiate equation 1 with respect to, so here with respect to x comma y comma z. So here separately, here dou f by dou x plus lambda times dou phi by, so here dou x, which is equal to 0. Now let's say this is my equation number 2. In the same way, so here partially differentiate with respect to x, this is my equation 2. In the same way, partially differentiate equation 1 with respect to, let's say, y. This is my dou f by dou y plus lambda times dou phi by dou y, which is equal to 0. Let's say this is my equation number 3. And similarly, partially differentiate equation 1 with respect to, so equation 1 with respect to z, this becomes dou f by dou z plus lambda times dou phi by dou z, which is equal to 0. Let's say this is equation number 4. Now eliminate lambda from equation, let's say 1, 2, 3 and 4, and find the value of x, y, z for which my function f of x comma y comma z is either maximum or minimum. So here is either maximum or minimum, and the method of finding lambda, so the method of finding x, y, z by using this method is called Lagrange's multiplier method. Is called Lagrange's multiplier method, and the equation, and this equation 2, 3, 4 are called Lagrange's equation. So here, so this is the Lagrange's multiplier method. Now here I will solve this example with the help of this method, that is with the help of this Lagrange's multiplier method. So here just observe one thing. So let's say if you have one function x, y, z, f, and this variable x, y, z are related by some relation, that is phi of x, y, z equal to 0. This is my constraint, and let's say if you want to find the value of x, y, z for which my function is either maximum or minimum, so for that purpose create the auxiliary equation with the help of this objective function f and constant by multiplication of lambda. So after that, this is your that lambda is your Lagrange's multiplier. So that lambda shows the effect here. If lambda is more, this means that my constraint have more effect on objective function. If my lambda is less, my constraint has less effect on my objective function f. Now partially differentiate equation 1 with respect to x. This gives 2. Differentiate y gives 3, and differentiate z, I got equation number 4. Now from equation 2, 3, 4 and 1, so here from equation 1, 2, 3 and 4, here eliminate lambda and find the value of x, y, z. So here eliminate lambda and find, and we get value of x, y and z. So here we get the value of x, y, z for which your function f of x, y, z is either max or min. So here this is the method of finding maximum of and minima of your function by using this method is called Lagrange's multiplier method. That is, find the maxima and minima by using Lagrange's multiplier method. That lambda is called the Lagrange's multiplier. So here this is the concept of Lagrange's multiplier method. So here now I will solve one example so that you will get one complete idea. So what is meant by Lagrange's multiplier method and how to solve problem with the help of Lagrange's multiplier method. So now just observe one thing. So just read this question. Here find the minimum value of my function x square plus y square subject to the constraint ax plus by equal to c. So here this is my objective function and this is my constraint. So here, and my aim is to find x, y such that my function this x square plus y square is either maximum or minimum, but in the question they are saying find the minimum value of my function. So here given let's say f of x comma y, given f of x comma y which is equal to x square plus y square, this is my objective function. So f of x comma y equal to x square plus y square, this is my objective function. I want to minimize my objective function with respect to this constraint ax plus by equal to c. So here with f of x comma y equal to x square plus y square with constraint, here with constraint ax plus by equal to c. Therefore phi of x comma y which is equal to ax plus by minus c which is equal to 0. This is my constraint f of x, phi of x comma y, and this is my objective function f of x comma y equal to x square plus y square. Now I want to find the value of x, y such that my function is minimum. So here my aim is to find, so here my aim is to find x comma y. My aim is to find here this x, y such that my f is minimum. So this is my aim. Therefore here the auxiliary equation auxiliary equation is, so here f of x comma y plus lambda times phi of x comma y, which is equal to 0. With this is my auxiliary equation. Now here let's say this is my equation number. So here I will give, so f of x comma y is x square plus y square plus lambda times phi of x comma y is ax plus by minus c, which is equal to 0. Now let's say this is my equation number 1. Now partially differentiate equation 1 with respect to x and y. Here I have just only two variables. So here lambda is constant, Lagranges multiplier, this is one constant number, and x and y are the variable. Therefore partially differentiate equation 1 with respect to x, keeping y as a constant. Therefore 2x plus this is 0, lambda, so y is 0, lambda times this is a, here the partial derivative of x with respect to x is 1, this is 0, which is equal to 0. Therefore from here lambda equal to, lambda a equal to minus 2x, lambda equal to minus 2x by a. Let's say this is my equation number 2. Now partially differentiate equation with respect to y. Here partially differentiate equation 1 with respect to y. So therefore 2y equal to lambda times, so this is b, which is equal to 0. Therefore so from this implies, sorry, lambda times, so this is plus, this implies, so here lambda equal to minus 2y by b. This is my equation number 3. Now just observe equation number 2 and equation number 3. Just observe equation number 2 and 3. Left hand side of both the equation 2 and 3 are same. Therefore right hand side must be same. Therefore from equation 2 and 3, therefore right hand side, left hand side is same, right hand side is same. Minus 2x by a equal to, this is minus 2y by b. So this implies here minus 2 gets cancelled, x by a equal to y by b. This now here x by a equal to y by b. So therefore y equal to, so here b by a times x. So here this implies y by b equal to x by a. Therefore y equal to b by a times x. So this is the value of y. Now if value of y is this, therefore the value of x. So here from here a x plus b times the value of here y is b by a. So here this is b by a times x, which is equal to c. Therefore a square x plus b square x, which is equal to c, and this is ac. Just multiply a on throughout this equation. So here a square x, a gets cancelled, this is ac. Therefore I will take x common, this is a square plus b square, this is equal to ac. Therefore x equal to ac divided by a square plus b square. Now just find the value of y. Therefore y equal to b by a times x. This is ac by a square plus b square. A gets cancelled, which is equal to bc by a square plus b square. So this is the value. Therefore the value of x, here find the value of x for which your function has minima. So this is my value of x and this is my value of y for which my function has minima. Therefore minimum value, here minimum value of function x square plus y square equal to, x square is, so here this is a square c square divided by a square plus b square plus y square, this is b square c square divided by a square plus b square, this is square. This is my aim. So here find the minimum value of your function for which, find the minimum value of your function. So here, so my aim is to find the value of x. This is the value of x and value of y for which my function is minimum. So this is my answer. So with this we can solve. So in Lagrange's multiplier method, f of x comma y is your objective function and this x comma y comma z are related by your constant phi of x comma y comma z. So our aim is to find the value of x, y, z for which your function is either maximum or minimum. For that purpose we need to create auxiliary equation f of x comma y comma z plus lambda times phi of x comma y comma z equal to 0, that lambda is your Lagrange's multiplier, and partially differentiate that equation with respect to x, y, z, so on, and try to eliminate the value of lambda. So while eliminating the value of lambda, you will get the value of x, y, z, for which your function is either maximum or minimum, and the method of finding the maximum or minima of your function with the help of this method is called Lagrange's multiplier method, and this equation 2, 3, 4 and this equation 1, 2, 3, 4 are the Lagrange's equation with Lagrange's multiplier lambda, which is undetermined. Thank you.